How's it going, Algebra 2B students? This video is the start of what we'll be doing for roughly the next 7 weeks. You're going to have basically one video, one assignment, and you have the whole week to do it. You should be receiving this video Sunday night, the 19th of April, or Monday morning, the 20th of April. And you'll have all the way till the following Sunday to do that, which would be the 26th. It'll have a due date of then. You're going to receive a worksheet via Google Classroom, and you don't have to print the worksheet. And if you feel like it and you have the capabilities at home to print the worksheet, then do it. But otherwise, you do it on a piece of paper, snap a picture of it, and upload it to Google Classroom. There'll be a spot for you to turn it in. So yeah, that's what we're going to be doing for the next 7 weeks. And I will keep it simple for you guys. You know how I am in the classroom. I never made any assignment that long. This assignment's going to be 5 problems. And again, you get a whole week to do it. So our topic is lesson 4.2. That's where we left off. You had a review assignment that I shipped out to you last week, and that was optional. That was in the assignment was listed as do it if you needed to, or review it if you needed to. But these are going to start being required. Okay. This is lesson 2, and it's called Pascal's triangle. It's named after a mathematician whose last name was Pascal. Now, Pascal's triangle is a triangle of numbers. And here's the rules. I'm going to write Pascal's triangle right here, and then over to the board to this side, I'm going to show you what you do with that triangle and how you use it for problems. So, here's how it works now. Pascal's triangle is a triangle of numbers. And the first row has 2 numbers in it, the next row 3 numbers, the next row 4 numbers, and 5 numbers, and 6 numbers, etc. Every row of numbers has to begin with 1 and end with 1. So that's why the first row is just 1, 1. Now, technically, there's supposed to be a 1 at the top, so it makes a nice triangle. That row is useless, so I don't even include it. This is row 1, 1, 1. Now, here's the tricky part. You are to add these 2 numbers together, 1 and 1 is 2, and put that right down below it between this open space. And then following the rules, the next line starts with 1 and ends with 1. And you do that for every pair of numbers. You add the 2 numbers that are side by side, you add them, put them down here, add them, put them down here, start with 1, end with 1. It is straightforward addition. So 1 and 2, add to 3. 2 and 1, add to 3. Start with 1, end with 1. So it starts looking like a triangle. It kind of looks like a set of bowling pins, if you will, if you know how bowling pins are set up. And we keep doing that, people. Now, I'm not going to make your problems that difficult. In the classroom, I'd probably make this triangle go on for a while. We're only going to go to row 5. We are on row 3 right now. We're going to go row 4 and row 5, and that's all I'm going to take you. But in class, if we were in class together, I'd probably go row 6 and 7 maybe. That's a little pushing it. But anyway, so here we go. 1 and 3 are 4. 3 and 3 are 6. 3 and 1 are 4. Start with 1, end with 1. And the last row will do. 1 and 4 are 5. 4 and 6 are 10. 6 and 4 are 10. 4 and 1 are 5. Start with 1, end with 1. So you guys, there's the first 5 rows of Pascal's triangle. And what they're used for is for problems like this. Now, in the review worksheet that you received last week, and in our last week of class together, we did some problems like this, but the highest we did was to the 3rd power. And I did that in the last video, and you had to write this down 3 times. You could only multiply 2 sets of parentheses together at once. So when it gets to 4, you'd have to write this out 4 times. X plus 2 times x plus 2 times x plus 2 times x plus 2. Only do 2 at a time, and it becomes a really long distributive property, and it's super easy to make a dumb mistake along the way. We use Pascal's triangle to shorten that process. Now at first, it's not going to look like it's shorter because it's going to take a minute to explain. Now again, the beauty of the video is if you're getting it, you can move to the next example, just kind of fast forward ahead. But if it's a struggle, you got to look at it, maybe re-look at it, pause it. You got to take the time to understand it. I think you all can handle it. Okay, I've been with you in class. I know what you're capable of, so you can do this. So here's what you got to do. The exponent up here tells you what row of Pascal's triangle to do. Now remember, this is row 1, row 2, row 3, row 4, row 5. So since it's the fourth power, we're going to do row 4. Now here's what you're going to do. I'm going to write this down here. Hopefully this little board's big enough. And I'm going to space out those 5 numbers, 1, 4, 6, 4, 1, across the board. That's going to actually be part of my final answer. So 1, 4, 6, 4, 1. Okay, so here's what you do. And this is a shortcut. Understand, the alternative is to write this out 4 times, distribute it 2 groups at a time, and do that. And if you, at the end, say, I hate Pascal's triangle, I'm going to do the distributive property. You can, but I'm telling you, experience tells me that's harder and more difficult. Okay, so here's the shortcut, the pattern that somebody, Pascal himself, took time to prove. You start with the first term right there. It says x plus 2. Start with x. We're going to put a piece of x in almost every problem. Here's how it goes. So you start right here, times x. So 1 times x to the 4th power. You start with the 4th power because that's what this problem is. X plus 2 to the 4th power. Every term is going to get an x. And the exponent is going to start with 4 here and go down by 1 each time until I run out of space. So this will be 4x to the 3rd, 6x to the 2nd. See, 4, 3, 2. 4x to the 1st. And I run out of space because you don't write x to the 0 power, you just blank. So we run out of x's, and that's how it should go. The first term should have the x, the very last number shouldn't have this x. Now, we're going to do a similar thing with the 2. X plus 2. 2's the focus now. The 2's going to start at this end of the problem, though. So down here where this 1 is, it's going to start as times 2 to the 4th. Again, the exponent starts the problem. So again, kind of get this an idea. The first thing in the parenthesis, x, starts in the beginning. X, 4, 3, 2, 1, gone. The second thing in the problem, which this case is a 2, starts at the other end and goes backwards like that. So this was times 2 to the 4th. This will be times 2 to the 3rd, times 2 to the 2nd, times 2 to the 1st, and I run out of 2's. You don't write 2 to the 0. It's gone. So that, when you look at the setup, the very first term should have only the x in it with the number from Pascal's triangle, and the last term should only have the 2 in it with the number from Pascal's triangle. Now, the tricky part, I just said fart, nice. The tricky part is that you now have to calculate, oh, by the way, between each term at this moment is plus signs. The tricky part is calculating each thing, because what each term should be is a number followed by x to the power. So this one's good to go. It just says 1x to the 4th. So I just write it as x to the 4th. You can include the 1 if you want, but I just drop the 1. Now here's the thing. I know this says 4 times x cubed times 2 to the 1st. Well, you have to multiply the numbers together and put them in front instead of 1 in front and 1 back. Now, I hope we all recall 2 to the 1st is 2. 4 times 2 is 8. This should be 8x to the 3rd. That's that term right there. Next, this term. 2 to the second is 4. That's 6 times 4. Again, I don't care that there's an x squared in the middle. You have to multiply all numbers in this term that are all grouped together. So again, 2 to the second is 4. 6 times 4 is 24. 24x to the second, because that's what it is, x to the second. So all answers should have number x. Number x, number x, number x. Next term. And by the way, you might need a calculator. You should have a calculator on your phone. You can use Desmos on a Chromebook. You can download even a nice graphing calculator app on your phone that'll work. So this one, 2 to the third is 8. 4 times 8 is 32. 32x to the first. Now you don't have to write x to the first. You can just write x. It's understood, but I like put it in there for now since we're on this distance, video thing. And then last but not least, people, 2 to the fourth times 1. 2 to the fourth is 16. Times 1 is still 16. And there is your final. Okay? So that's how Pascal's triangle works. All right? So there's example 1. I'm going to do 2 more. I'm going to pause, erase, so you don't have to sit there through that. Let me pause a second. Okay, welcome back. Here we go. Look at that, magically erased. Boom, new problem up. Okay, so I'm going to accomplish 2 things with this problem. Number 1, I got a bigger number here, 7. That's going to, x plus 7. That's going to make some of the calculations come out bigger numbers. And then secondly, I did a bigger exponent. I went to the 5th power. And that's as high as I'm going to go, because that's as far as my Pascal's triangle goes, is row 5. So this time, because it's a 5th power, I will write out row 5, which is 1, 5, 10, 10, 5, 1. Okay? And we're going to do the same thing we did last problem. We're going to start with the first term, which is x. And we're going to start saying times x. And it's a 5th power. So we're going to start here. X to the 5th. And your exponent goes down by 1 till you run out. So this is times x to the 4th, times x to the 3rd, times x to the 2nd, times x to the 1st. You run out. You don't write x to the 0. Now I'm changing our focus from the x to the 7. The 7 starts at the other end. Times 7 to the 5th. Times 7 to the 5th. And you work your way back. Times 7 to the 4th. Times 7 to the 3rd. Times 7 to the 2nd. Times 7 to the 1st. And you run out. You don't write 7 to the 0. I'm like, just like last example, the first term should have x in it only, and the last term should have the times 7 in it only. No x. Plus signs between the groups at the moment. Okay, this time I got my trusty calculator because the numbers are rather big at times coming up. But let's get that final answer down here, people. Now the first part right here, that's just 1x to the 5th. Okay, here, not super fancy yet. Remember, you're multiplying all numbers together, putting the x second. I don't care that the numbers aren't next to each other. They get multiplied. That's 7 to the 1st, so it's just 7. So 5 times 7, that's 35. So plus 35x to the 4th. It's x to the 4th. Okay, this term. Getting to be a little bit more of a pain, but I can pull this one off without a calculator just yet. 7 to the 2nd power, that's 49. Don't call that 14. 7 squared means 7 times 7. 49 times 10, 490. X to the 3rd, you can see that is. See, that doesn't change in the problems that we're doing. Okay, next group, getting a little bit large, so I'm going to just check on my calculator. What's 7 to the 3rd power? That's 343. times the 10 that's out front from the Pascal's triangle. I think we all know that that's 3,430, but if we don't, that's what this is for. 3,430 x to the second, you see. Here, getting even bigger, 7 to the fourth. That's 2,401 times the 5. 12,005 x to the first. See, the same x pattern happens where we started. See, x, 5, 4, 3, 2, 1. The last term doesn't have any x's. You and I just got to do 7 to the 5th. And that's 16,807. So there we go. There's a kind of a problem with more terms and bigger numbers. Like I said, you can pause this anytime and kind of look at how I calculated this and kind of mess around with an online calculator. If you just had a basic scientific calculator at home, that works too. All right, I'm going to pause one last time and bring up one additional thing. All right, back at it. Final example. And I'm accomplishing one new thing with this example. What happens if the sign in the middle is minus? That does create an issue, especially with the calculators. I chose the number 6, x minus 6. That's still fairly large. It's kind of like 7, so we'll have some bigger numbers in here. But also, I only did it to the 4th power again, so I went back to the shorter problem. So 4th power means we'll be using the 4th row of Pascal's triangle here. 1, 4, 6, 4, 1. Spread that out right here. 1, 4, 6, 4, 1. And start our pattern over. Now the first thing you're getting accustomed to, you're like, okay, 3rd time I've seen this because it starts with an x again. And you guys, I have kept these because of the situation here being away from each other. In the classroom, I would make this part probably more challenging. Like I would include things like 2x minus 5 and 2x plus 3. But we're just going to keep it straightforward because of the situation. Just get you exposed to this a little bit. So we're starting with the x again, and this time it's to the 4th. So here, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, no x on the 1, just like the first two examples. Now, new thing, be careful. You have to call this negative 6. So when I start putting the number in down here, negative 6 to the 4th is what I write. So here it'll be times negative 6 to the 4th, times negative 6 to the 3rd, times negative 6 to the 2nd, times negative 6 to the 1st. No negative 6 in the first term. Just like the first two examples. X only here, negative 6 only here, in the middle combined. Now, I am going to write plus signs for the moment. They're not all going to stay plus, though, because there's a negative 6 involved. Now I'm going to mention something right now because here's an area where students get a little bit stuck sometimes, and it comes down to how they enter things in this calculator. You need to know that in this, and I'm going to do every part individually, but negative 6 to the 1st is negative 6. So that term's going to end up being negative, and here's where you got to be careful. If you don't enter negative 6 squared properly, do not enter it like that. I don't know if you can see it. There you go. You have to put parentheses around that, because otherwise it's going to come up negative 36 and you're going to think that that's correct. It should be like this. See the negative 6 in the parentheses? And then it comes up 36. And you have to be careful. So that kind of says, negative 6 to the first power, odd power gives you negative, even power gives you positive. Negative 6 to the 3rd will be negative. Negative 6 to the 4th will be positive. So you guys, when I get to this final answer here in just a couple minutes, the signs are going to go alternating. Ones will be positive, the ones following it will be negative. Okay, now the first term doesn't have any fancy stuff. That's 1x to the 4th. But here we go. That's negative 6 to the first, which is negative 6. 4 times negative 6 is negative 24. You must write minus 24 x to the third for that term. Now this term, as I was just explaining to you, negative 6 squared is 36, positive. Times the 6 out front from Pascal's triangle, that's 216, it's positive. 216x to the second. That's an x to the second term. Okay, here. Negative 6 to the third. That's negative 216 times the 4 from the Pascal's triangle. So times 4. That's negative 864. X to the first. And then the last one is negative 6 to the fourth. Yeah, it's times 1, but you know times 1 won't change. That's positive 1296 plus 1296. And there it is. You notice that the signs are alternating. Okay? Positive first term, negative second term. Positive third term, negative fourth term, positive fifth. That is how it should go. Okay? So, you guys, attached with this video in the Google Classroom that I ship out on Sunday night or Monday morning, this video and the worksheet will be there. 5 questions. No more difficult than what I just showed you. So again, slow down and re-look at things. Now, the way that I'm going to do things, and I'll probably explain this in the email, but I'm just going to say it now that we're here together. I'm probably not going to do a Zoom meeting to answer questions. There's been some issues with Zoom. So basically what I think I will do is ship out another video, say Thursday or Friday of the week, answering questions. And you guys can send me messages saying I can't get this. I might post the answers like on Thursday to you, ship those out, and then if there's questions, you can kind of send me the questions and seeing if I have to answer anything. Now you might see the answers and say, oh, I see my mistake. And I'll post my work with the answers. I won't just ship you out the answers. I'll show you work. So you can decide like, oh, I see where I went wrong right there. So then you can ask me questions after that, and I'll address questions like say on Friday or something like that. I don't know. This is all new, so I'm trying to figure it out. Like I said, I just don't know that I want to do a Zoom meeting. It doesn't always seem to work as nicely as you want. So anyway, take care of yourself, guys, and hope you're all doing well.